and we are far better than these pigeons. So they generalize from the already seen and make predictions. So this is our basic aim, that we should be able to do predictions based on earlier information. So this is what neural networks or biological, maybe artificial, are good at. So these neural networks are good at making the predictions based on earlier information. Now, when you go to the very early efforts in this biological field, the search of what is brain, you may start your journey with this first event, that first use of simple microscope came into existence to view living cells. That was in 1665. So the Robert Hooke was the person who could do this observation using microscope. So you can see the invention of microscope is way back. It is 1665. Then there is a huge gap. 1839, cell theory was proposed. Okay, 1839, cell theory was proposed, and then again after maybe 30 years, in 1870, Camillo Golgi developed his silver staining method to stain nerve cells. Okay, so he did the pioneering work in staining nerve cells. So he could actually isolate nerve cells using silver-based method. Then, after some time, that is after 17 years, say Ramanika Kajal uses Golgi's technique and proposes neuron doctrine. Okay. So it's way back 1887, and then the journey of biological neuron, then understanding of neuron within your brain starts. So the coin neuron came into picture in 1891, and in 1897 the word synapse came into picture. So what this exactly is, we will see later on. And these two persons got Nobel Prize in psychology or medicine in 1906 in recognition of their work on structure of nervous system. So Camille Golgi and S.R. Kajal, so they did the pioneering work in this field of biological neurons. So you can see some images, handmade images by Ramanika Kajal. You can see these images. These images were actually drawn by Kajal, looking through the microscope, and he could find out the actual neurons. You can see, I can isolate, suppose this is one neuron in our brain. The structures are like this. So this is an actual structure in your brain. So if you have a close look, you can see here, you can isolate one neuron like this, another neuron is like this. Okay, so it's a very complicated structure, and these are all connections, say, going or running throughout this structure. Okay, maybe this neuron is connected to some other neuron, say here, like that. Okay, it's a complicated structure, and this fellow actually saw these things through this microscope, and he did these paintings on his own. So it's a very beautiful painting of your actual neuron. Now, if you see closely how it looks, so if I isolate one neuron, so say this is the structure like this. So here the things are, coming from other neurons. Say it's like input to this neuron. Okay, this may be input to this neuron, and just 1 second. I should see from bottom. So these are actually inputs. So sorry for the earlier trying. So I think these are inputs, and this is axon. Axon is the output of neuron, and these are called as dendrites. These are all inputs, and outputs are then connected to other neurons. You can see a spot here. Actually, I missed that spot earlier. So this is the spot that identifies where is cell body of your neuron, or its nucleus of that particular neuron cell. So if I draw something like this here, structure is like this. So these are all inputs. So this is the cell body, or the processing unit, and this is axon, that is producing output, or this is output terminal. You can say axon is output terminal, and these are input terminals called as dendrites. Okay, now if you see a particular input, say maybe if you put a probe here like this, suppose I am putting a probe here for one of the inputs, then you can see actually electrical signal like this. Okay, see, these are all impulses going to a neuron continuously from different inputs. So what happens is, at this position there will be some kind of integration over a period of time. So all the signals actually will be added over a period of time, and if this sum is greater than some threshold, then the axon will get fired. Okay, so output will be produced. Now quickly we will revise this. So what happens? So inputs are coming from different neurons like this, and what this element will do, it will integrate all these signals coming from different neurons. If it is more than a threshold, then it will pass on the signal to the subsequent neurons. Okay, and this phenomena repeats for every neuron, and the complex structure of connection will be responsible for your behavior of your circuit. Now the same thing, inspired from this biological neuron, we are trying to implement in artificial neuron. So if you understand this concept, then the other things are very simple. Now if you look at your brain, there are different portions of your brain responsible for different kinds of works. Say for example, this is some sensory area, say this one. is responsible for skin sensation, that is temperature, pressure, pain. So you register your things here. Now if you take frontal lobe, you do the controlling of movements, problem solving, thinking, personality, then mood, behavior, all these important things are lying over here, front side of your say face. Now there are some cerebellum area, say which is here, which is responsible for posture, balance, and so on. There is some optical lobe which is responsible for your vision, perception, and so on. So eye is the only part of your brain which you can see physically from outside. Remember, your eye is also part of your brain, which is only visible thing. Other part of your brain is not visible. So from here to here, there are many connections. So these are all called as optic nerves. So whatever is captured by this eye, that is your natural camera, is connected to this optical lobe, and lot of image processing takes place when a signal from this eye travels to the back side of your brain. So if somebody gets big injury from backside, you will see that his vision is lost. Okay, so backside of your brain is very sensitive, and your vision is totally dependent on backside of your brain. Obviously, I must be good, and then you can understand the word. So there are many things in your brain, and there are many sections in your brain responsible for different behavior. Now, normal computer system are good at rule-based working, that is, do what the programmer wants to do them, and not so good at dealing with noisy data, dealing with unknown environment data, massive parallelism, then fault tolerance, adapting to circumstances. Now, neural network is for our rescue information processing paradigm inspired by biological nervous systems such as our brain. So structure is large number of highly interconnected processing elements, neurons working together. So like us, we learn from experience. This artificial neural network will also learn from experience. Okay, so let us now jump to the very first mathematical model of artificial neural network proposed by McCulloch and Pitts. These were two scientists. They have proposed the first model of ANN, or a simple neuron. So how it was? So it was proposed in 1943. So not that back, or it's not that very old, but relatively it's new. But you can see the progress is very huge. The very first mathematical model came in 43, and today's scenario, if you see after say 80 years or so, the world is moving around artificial neural network or artificial intelligence. Now, try to understand this model. If you understand this, the half work is done. So it's very simple actually. So this is the input. Now I will call it as input vector. And generally we represent this input with a capital letter X. So whenever I write capital X, it consists of features x1, x2 up to xn. So x1 or xi, I can say, is individual feature. A collection of n different such features will give me input vector. Now there is some W written over here. These are called as weights or importance to a connection. In biological term, it is called as synapse. So every connection here has some importance. This importance is assigned by this particular neuron. So if importance is more, this signal will contribute more towards firing of this neuron. If importance is less or it's negative, then if say contribution of this input will be less in firing this neuron. So what we do in the first model, we use input to be binary. So input and actually output, they are ones or zeros. So input and output are binary. Weights can be plus or minus 1. So these weights can be plus 1 or minus 1. Now what happens, your output O here is equal to 1 when your summation here is greater than or equal to some threshold value. It will be 0 if your sum here is less than the threshold. So you can see here, if I draw like this, this is my net. I call this sum here suppose as net value, and net value, if it is more than this threshold, say equal to 0, then your output is fired and it is 1. Otherwise, if your net is less than 0, it is 0. Now I can change this threshold as per my wish. Suppose I put here threshold equal to 2, then what happens? This is my 2, then neuron gets fired when my sum is more than 2 or equal to 2. Otherwise it will remain 0. Okay. Now this is the logic. So you can see here, this is a weight, I can say weighted sum. So you can expand this. Suppose net, I can write here net equal to x1, or I should write weight first, w1 x1 plus w2 x2 plus and so on up to wn xn. So in short, we can write this in summation form, that it is say wi xi I equal to 1 to yeah. So this is my net. Okay, so we compare this net value with the threshold kept here. If it is more than that, you will fire and produce 1, otherwise it will produce 0. So this was the simplest say implementation of say actual biological neuron in the form of artificial neuron. Now let us take this simple neuron. There is only one input here and one output, obviously, with t equal to 0. Now what happens, if I put this x1 here, I can take two possible positions of x1, say 0 and 1. So when this input is 0, 0 gets multiplied with this minus 1. So net input is 0. So when my net is equal to or greater than 0, I am going to produce 1. So this will be producing 1. Now if I take 1, so this 1 gets multiplied with minus 1, so net is equal to minus 1. So what happens? This net is now minus 1 and my threshold is equal to 0. So is this correct? This should be actually 0. Okay, so output should be 0 here. This is the wrong entry. So finally what happens, if I make this table here, if this is my input X, and if I take final output as O, if I apply 0, it will produce 1. If I apply 1, it will produce 0. So this is the implementation of a NOT logic. Okay, so what I have implemented with the help of a single neuron is a NOT logic. Now if I take this further, I have now two neurons. And I can make 8 possible combinations of input because there are 3 inputs. So I write here x1, x2, x3 like this, and then I calculate net for this, and then I pass on this net to the second neuron, and I can then finally compute the output. So if I apply 0, 0, 0, 0, 0, 0, what happens? This 0 gets multiplied with 1 plus 0 into 1 plus 0 into 1. So this net value will be 0, which is less than the threshold. So output will be 0. So this 0 gets multiplied with minus 1. So net value is 0, which is equal to this threshold. So output is finally 1. So input here is 0. Output here is 0 for first neuron. Then this 0 gets multiplied with minus 1, so this is 0, and finally output is 1. So if you calculate for remaining things, okay, so it will look like this. So this is the complete table. If you take one by one all these combinations, so this is now my input vector, next input vector, then I take this input vector and calculate all these outputs here for every combination. Now this is the NOR logic. So whenever all inputs are 0, I will get 0. I will get 1 as my output, and for all other combinations, I will get 0 as my output. So this is a NOR logic. Now you know that NOR is a universal logic or universal gate. So if you are able to implement this, you can implement any logic. Okay, so this proves that I can use this kind of technology to implement any kind of Boolean logic. Okay, now similarly, if I take this circuit with 4 neurons, it can implement a NAND logic. So output is 0 whenever all inputs are 1. So this is giving you a NAND logic. So you can implement NOR, you can implement NAND, that means you can implement any Boolean logic. So this small kind of idea of thresholding was able to implement any kind of Boolean logic. So that was proved in 50s, that McCulloch-Pitts model, very simple model with binary input, binary output, and just plus or minus 1 weight, can implement any kind of logic. Now if, for example, you can try this here, that if this is the circuit which is unknown to me, then I can make this as x1, x2, x3, then write here 0, 0, then 0, 0, 1, and so on up to 1, 1, 1. So this will give you all possible combinations. Then find out, say net 1, that can produce output 1. Then this will be passed on here, and this extra input will come here, and that will give you net 2. This net 2 is compared with this particular threshold 1, and accordingly output 2 will be produced. Okay, so you find out output for say everybody here, for that is for all 8 possible inputs, and then use your K-map technique. Use K-map technique to find out what is the logic here. Say you can say x1, x2 bar bar, and so on. Something like this. So this will be x3 bar and x3. So accordingly, suppose I take this combination, then entry will be, say this is 0 and all the others are 0, then you have to take entry here. If it is 1, then you will take entry here. Okay, like that you can enter all the data and simplify this K-map, and that will be the logic implemented by this particular circuit. Okay. Now these things we will see tomorrow in next class. Now what you have to do is in your Google, go to your Google class. I can show you. Go to your Google class now. There is a small quiz for you. So you have only 5 minutes left. You have to solve 1 or 2 questions there quickly, and you have to go to this attendance link. Click this link and fill a form that is there to give your attendance. Okay, so this is compulsory in almost all classes. You have to do this. So now you can attempt this quiz. So I will stop here. You try to solve that say quiz.